Whenever we talk about going to Mars, there's usually one thing we don't mention. Unlike with the ISS, which can be resupplied in less than 3 days, it takes around 6 months to resupply Mars. Worse yet, a launch window only opens up every 26 months. So clearly, that's a problem when we're establishing a colony there, unless we can get to Mars in less than 2 months instead of 6. And that's what the Solar Thermal Starship intends to do. But where would we get the energy? From the source of all energy on this planet, the Sun. There would be 2 huge solar reflectors that would provide the energy for this engine. But no, this is not a solar sail. These solar reflectors would concentrate the heat on a rotating drum that would reach temperatures of around 5,000 degrees Celsius. But you might be asking, wouldn't this heat just melt through the rotating drum itself? And yes, with normal steel. But with rhenium, which has a melting point of around 5,500 degrees Celsius, the melting wouldn't occur. Even if it was to happen, rhenium as a liquid is very stable, which makes it an incredible heat exchanger for transferring the heat of the sun into the liquid hydrogen, then converting it into atomic hydrogen and ionizing it, all at the same time. Funny how much you can do with just 2 mirrors. Anyways, when the hydrogen is superheated and ionized, it's then driven out the nozzle of the rocket through electromagnetic forces. Now if you look at this diagram, the liquid hydrogen has the added benefit of serving as the active coolant of the drum wall, so that it doesn't melt. Now the secret with rhenium is that it absorbs 80% of the heat energy, compared to the mere 20% absorbed with the solar panels used for solar electric propulsion in the Lunar Gateway. But how does this fit in the bigger picture of getting to Mars? Well, we start off with a normal launch, escape the atmosphere, and instead of refueling, 2 more starships would launch the 2 mirrors, which would dock with the main starship. The engine and mirrors would start, and instead of 6 months to get to Mars, it's now more like 60 days. And since the starship doesn't need to get itself to Mars, it only needs enough fuel for powered landing, which is much less than if it was to get all the way to Mars by itself. This saves fuel, increases cargo, and dramatically reduces the time needed. We could also use this method with the Mars Direct 3.0 plan, which you can check out up here. It would make the mini starship able to carry almost as much cargo and people as the original huge starship. But worst of all, this isn't some new method of propulsion that we've just discovered and uses like the 5th state of matter and can only be made in space or anything like that. This has been looked at for over 60 years, and yet nothing's been done about it. By the way, the solar moth can go at around 12 kilometers per second compared to 3 kilometers per second a traditional chemical rocket would go at. So the title wasn't clickbait. The Solar Thermal Starship is 4 times more powerful than the normal starship. Thanks for watching, and I'll see you on Mars.